I'm Dean. I'm a developer at Yeti. Hi everyone. I'll be talking today about a hardware project that we worked on. It's called Emoji Ticker, and this is just a talk about how it works. I'll be going over some of the software, or pretty much all of the software, and we're going to have a lot of code snippets. Feel free to ask me questions whenever. I welcome them. Cool. So, talk about Emoji Ticker. So what does the Emoji Ticker do on a high level? All it does is it polls the Gotta Go server every 5 to 10 seconds. For each poll, it gets a list of all of the excuses that have been activated between the last time it was called and the current time. And then it displays all of those emojis in that list on the LED matrix. And here's a quick parts list of the hardware that went into it. Just a quick note about the hardware, because it was very simple to put together once I knew what I was doing. Raspberry Pi, which you need because that's the center of everything. The Wi-Fi card attaches the Raspberry Pi to the internet, which is what we need in order to communicate with the Gotta Go server. Jumper wires and LED matrices. The jumper wires are for attaching the Raspberry Pi to the LED matrix. Otherwise, you don't get the beautiful light show. And the power sources for everything, because you need power to run electronics. So the general idea of the Emoji Ticker is that we have a Raspberry Pi that communicates with the Gotta Go server on its own, and then we receive a response, we process that response, and then we send the processed response over to the board, which does all of the lights. So how do I use the Raspberry Pi? It's exactly like any Linux web host. You can SSH to it with the username and the IP address. I actually have it on the whiteboard to everyone's right. It can be rigged to receive requests like any web server. So you can use a web framework like Django, Flask, or Tornado on top of a web service like Nginx or Apache, and then actually run a website or a web application from your Raspberry Pi if you so choose. You can also rig it to send requests. So Python has a bunch of libraries for sending HTTP requests to servers. URLlib2 and requests are popular. I had a bunch of Tornado code in the first version of the Emoji Ticker, so I just decided to use whatever Tornado had, which was their HTTP client instance. We use Supervisor to run Python code in the background so that every time we run the Emoji Ticker, I don't have to have a terminal or a console window open. And we use cron jobs to start and stop the supervisor. And we can clone programs onto it with Git, which is really nice. You can also use SFTP, which is a file transfer protocol. It's also secure. Or you can do it the old-fashioned way and use like a USB drive and click and drag onto, and use like the operating system on the Raspberry Pi as like a way to do that, which is pretty cool. In any program that you might need, you can install through apt-get, because Raspberry Pi Raspbian, the operating system that you use, is related to Debian. So you can use the apt-get package manager, which is pretty cool. Quick note on the differences between the Arduino and the Raspberry Pi. I read a bunch of blogs, and this is what I came up with. With the Arduino, it's a microcontroller. So what that means is that you have a piece of electronic that can perform one task or maybe a handful of tasks, but every time you have to like flash software onto it, it's not something that kind of lives and breathes on its own. What's cool about the Arduino Uno is that it has both digital and analog pins, and with analog pins, you can actually hook up sensors to it. And because they're like specifically for analog purposes, you can buy like really cheap sensors. Whereas with digital pins, you'd have to have like an extra board that converts the analog signals, because the real world is really messy, into ones and zeros that computers can comprehend. Another thing about the Arduino is that the language that you use to create software for it is compiled, which means that it runs through a program that converts, say, like my for loops and my variables into ones and zeros, and that's flashed onto the board. And they tend to be faster because you're not doing that every single time you run the program. You do it once, and then it's like clear sailing from there. A downside to the Arduino, though, is that if you get like just the board, then you'll have to do some soldering required. You have to be good at soldering in order to get good with an Arduino. On the other hand, there's the Raspberry Pi, which is a full computer. It has its own operating system, like Mac or Windows, but in this case, we use a Linux distro called Raspbian. All of the pins on the Raspberry Pi are digital, so they only communicate in ones and zeros. When you want to get language, or if you want to get hardware interacting with the software on the Raspberry Pi, you have a lot of choices. You can go directly to the low-level code and write embedded C. Or you can go even higher level than Python and do Scratch, which is a drag-and-drop programming language that was invented by MIT for teaching kids how to program in a more visual way. Most people, though, will use Python's RPI.gpio library. And Python as a language is generally interpreted, which means that whenever you run a Python program, it has to run through an interpreter first, and then it does the code. I definitely recommend the Raspberry Pi for people who are beginners to like IoT or hardware, who are also coming from a web background, because a lot of the tools are the same. Like if you know how to use Linux, you can easily do projects on the Raspberry Pi. Another nice thing about the Raspberry Pi is that you don't necessarily have to do any soldering. A lot of it works with plug and play with male and female jumper wires. It's pretty nice. In short, I would recommend the Arduino for like managing low-level tasks, like sensors and basic hardware, where the Raspberry Pi is better suited for higher-level stuff like networking and web shenanigans. All right, so now we're going to dive into the process. What we're seeing here is just a basic request and response loop. So the Pi will send a request to Gotago and then receive a response back. So the first step is we got to contact the Gotago server. I'm going to use Tornado's HTTP client to make a request, and then we'll retrieve the response and hold on to it or put it somewhere. Quick note on the polling mechanism. This code kind of does everything that the program does, specifically the method emoji handler.get. And then once it performs that magic function or magic method, it calls itself and just restarts over again. I actually got into an argument. Someone told me that this isn't recursion, and I thought it was recursion. But it turns out recursion is you have to have like a convergent, like you have to have a base case. So it has to end at some point. And this is basically an infinite loop. So cool note there. This function is run inside emojihandler.get. I called it fetch from Gotago. And so this is the point where we start contacting or pinging the server. And so the first line is just we set a response variable and we say client.fetch. And client is just an instance of Tornado HTTP client. And then what it takes is a request object, which is also like a Tornado HTTP request object. And I'll show you how to assemble that in the next slide. But we take the response, we process it with a JSON module. And what's cool about this is it just takes like a JSON string and it parses it into like native Python data types, which is awesome because then you can now do enumerating, you can loop over things, and it's nice to be able to do that. For each object that we get in the result, we store it in a buffer called Emoji Buffer. And I will go over like what the data type looks like for that as well. So in the method self.assemble request, what we have is we're essentially just creating a request from scratch. So we have a URL, and I also have an environment called Gotago server, which means I can change the environment or I can change the domain name to like what I'm sending to. So if I want to test this out on a development server or like even a local server in the office, I can do that pretty easily just by changing like something on the Raspberry Pi. We also have a last time and a current time, and I'll go over what those are later. But last time essentially is what we were talking about earlier with we just want to get the last time it was called and the current time. We set the headers to be, I have a custom header here called emoji auth, and I'll go over later why we need like our own special authentication header for that. And so we put all of that into an HTTP request pot, and then we return that. And so once we do that, we end up going through like the rest of the program. And so we have a request, and it looks like this. We have headers, and this is just a fake string. Prezi presentations are public, so this isn't the actual key. But we have this. We have a URL, and this is what it would look like on production, and our queries. And so we'll use that later to kind of filter through some of the data. So the next stage is in the Gotta Go server. So these are just the pieces of code that I changed in the Gotta Go ecosystem in order to get this to work. So a quick note on deployment. Whenever we deploy something, we have like templates for all of the configuration files. And so I had to edit the configuration file for Nginx so that it would pass through my emoji auth headers. And this is important because otherwise we wouldn't be getting that, and the response would be just a bunch of blank lists, which isn't good. So after going through Nginx, like the web layer, we hit the actual web application, which is run primarily through Django REST framework. And what happens with the request is it goes down through a file called urls.py, and that maps the URL to like an actual method in Python, which is pretty cool. The method in Python that we actually hit is in a file called viewsets.py, or I think view.py. And the specific one is called emoji viewset. And so emoji viewset, what's nice about Django REST framework is that you can create endpoints for web servers really quickly. This is done in like less than 10 lines, which is nice. You have the first line, which essentially creates an endpoint that all it does is it spits out a list of data. And then you can set up some permission classes. Permissions just tell the server, can I give the data to someone, or can this person edit data? And it's just like a true or false thing. Serializer class is, it takes whatever data is in the database, and it converts it into a string in JSON format and sends it back to a response. And then query set is just like the pool of all of the data that we want. And so the pool of all the data that we want here is the excuse data, because that table has all of the beautiful emojis that people have been posting. We have a method that we override called getQuerySet, and that kind of pulls the queries that we put in our request and says, we don't want all of the excuses, we just want the excuses between the last call and the current call. And yeah, so I will also show you kind of how we set the custom modules. So the serializer class is very simple, 4 lines of code. You just set a serializer to be inheriting from like a model serializer. You set the model so it knows what kind of data it's looking at, and you set the fields so that it knows what to spit back out at you. And so we want the ID, the emoji, and the created attributes. The custom permissions I thought was pretty cool. I'd never dug in and done custom permissions before, but essentially all we're doing here is we send back our emoji auth key that we had in our header early on, and we compare it with like a configuration variable that we have on the server, which I called emoji ticker key. And you just compare them together. If they're the same, then data is yours. If they're not the same, then you'll get an empty list. Cool, so we have our response. And here's like an example response. We have a count, which is like the number of responses, or the number of data pieces that we want. We have a next and previous method, or next and previous attribute. And that's because the endpoint that I used natively uses pagination. So if we had more than, say, 20, then the first 20 would be in this results list. And then the next 20 would have a URL pointer. And you can actually access that URL and look at all the others. But most of the time, every 5 seconds, we don't get more than like 20 emojis, which is a good thing. But we already have all of that scalability in place, which is nice. And so looking at the results, we have three emoji objects. We have like a smiley emoji, a poop emoji, and a girl flipping her hair emoji. And they are kind of ordered in like the order that they happened in. So if you look at the dates, I mean, we won't generally pull emojis from the year 2010 because Gotta Go server didn't exist back then. But it's just to kind of illustrate that. Okay, so now we're going to look at what happens when we have the response and what we do with that response in order to get lights to show up on the board. So that method from earlier on, fetch from gotta go, kind of shows us where it goes from there. We have the response that's parsed through JSON, and then we store it in this mysterious thing that I mentioned earlier called Emoji Buffer, which is like a specific data type that I wrote. And the data type looks like this. It has a list that carries the emoji in memory, it has a last time, and it has a current time. It also has some built-in methods too. The built-in method that is most important is buffer submit, and this is the method that takes all of the emojis, it pulls it out of the list, and it sends them through to the board. And so just the general structure is we reverse the list. We kind of have to because we want to get the more recent emojis first, followed by the earlier emojis. And so we just run it through a loop to call this run submit method on all of the emojis. And we also pull the emoji attribute out of their own data structures. And the run submit method looks like this. We clean up the emoji. So when we start out, we run .encode Unicode escape. That gives us a nice looking string with a U, 4 zeros, and then a few more numbers. Then we want to isolate like those last few numbers, and then we plug it in to a path. And so this is pointing to an actual file on my Raspberry Pi. The path that it's looking at is home, pi, emoji, Unicode, and then .ppm is like an image file. And then now that we have like a path to that image file, we actually call another program, which is written in C. We run this program, which it's basically a demo program. You can feed it images, and then it'll scroll it across the screen for you. It was nice that they had that functionality built in. The only issue with that is that if you have to, I had to use a module called subprocess, which is asynchronous, which means if I call this, then it'll call the next thing after that immediately. It won't like wait until this is done before calling it again. So I had to set time for it to sleep in between. And I gave it time to sleep, and then I said, kill all of the instances of LED matrix afterwards. So sometimes, if it's especially glitchy, you'll see an emoji come across the screen and it'll shut off immediately. And that's not on purpose. I'm still working on the tweaks for that one. Yeah, so just a high-level overview. This is exactly what is in that master method. We set the time, so last time is set, current time is set, and then we run the fetch from gotta go method and the buffer submit method. And so in 2 lines of code, I got steps 1 through 3 all done, which is pretty cool. And yeah, so some lessons I learned. When there's a shell, there's a way. So using tools that we already know how to use was really helpful. It made it a lot easier, and I could parse through like what I wanted to happen a lot better. And learning how to focus on what the input of something is and what the output of it is, and then fleshing out the steps in between. I think when starting any new project, small or big, is really important. In this project, the input was that we were getting data from gotta go. The output was that we got emojis on an LED. And so the steps in between would be like, how do you get the data from gotta go in the first place? How do you store the data? And how do you get the data onto that LED screen? Yeah, so that was my presentation.
What was the hardest part about this? Like once you kind of figured out how to like make the hardware work, because I know that was neat for you, like what was, I guess, the most difficult part for you?
So the difficult part, I think, was like trying to figure out, like, do I want it to be a server that like collects data whenever something happens, or do I want it to like send out like requests actively? And I started out with the first one, and then had to completely rewrite everything because it was destroying the internet at our office. Yeah.
That was actually my question was, why are we not just seeing emoji real time instead of why are we like polling every 5 seconds?
I think in order for us to be able to do real time, we would need like some sort of, well, we did have it in real time in a sense because in the beginning, because I had it whenever we created an excuse on the gotta go server side, I actually wrote a hook that would send a Celery instance to like send a message back to my Pi at the office. And it wasn't feasible because all of that traffic was going through our router and bogging down our like internet service. If I had like another server that I could somehow, if I had like a full web server, like a full like server farm or whatever that I could hook up to our emoji ticker, then that would be feasible, I think.
That's good to know. Do we know like why? I mean, it doesn't seem like a very high intensity task to send like 3 pieces of data every 1 like second, or whatever, however many emoji there are, like maybe 1 a second tops. So
yeah. So what ended up happening was we would, at least when we started, like when the Gotta Go server was first released, we had like a huge like influx of people activating. And so all of that influx was being sent back down to my Raspberry Pi and through our router. So it was more a matter of scale. I maybe could have organized like the hook to be a little bit more lenient, but then it would still require some polling, for sure. Yeah.
The emoji objects that you were showing us, are those all manually written, or are they pulled when an excuse is made?
So are you referring to like the response?
Yeah.
So what's nice about Django Rust Framework is it kind of, if you put all the pieces together, it kind of does all of that for you. So I didn't have to like write a method that'll assemble this JSON together. So that was nice. That was probably, the Gotta Go server aspect of it was probably the fastest part of the project because the framework is very thorough.
How long does it take to request data from the server and then pull it back to the display?
So a general, like it would be a general request response loop, which is like, say you wanted to go onto our website, like at yeti.co. It would just be as fast as it takes for it. Actually a little bit faster because we're not sending back the HTML, the JS, or the CSS, or any other crap. We're like sending back JSON. So it's, I would say a little bit faster than most web communications. Yeah. Any other questions?
What did I can't remember his name, but the guy that came in and helped you out?
Yeah.
What did you specifically help me out with?
So Adam was helping me out with the hardware part of it, which I didn't include too much here because essentially, like all you had to do was plug things from the Raspberry Pi into the LED matrix board, and that was not as exciting, I think. But like figuring out like where the pinouts belong, what pinouts I should be reading, like what sources I should be pulling from was important too. And so he like looked at a source that I hadn't found yet or that I like kind of glazed over, and he interpreted it into something that we could use. And it made it so we can do cool stuff.
Was it just because the pin inputs were wrong and like in the wrong places? Or?
Yeah, so it was that the wires were plugged in the wrong places because the documentation I was using was like very high level, like not really digging into the dirt. Whereas he showed me like a source that was a lot, it was harder to read, but it was also more accurate.
Okay, cool. So I understand that you're using the Raspberry Pi 2 and you're using Raspbian OS, which could be used to multitask. Are you going to use the Raspberry Pi in the future for other kinds of processes, or is this because of the way you set it up, kind of a single time use, and it's only good for this one thing?
So funny question about that. I sometimes store things on this Raspberry Pi still. It's nice that I can like still interact with it in the way I would a general thing, but like if I have a file I want to send to someone, or like if I want to store a file somewhere else, then sometimes I'll use the emoji ticker Raspberry Pi, and I'll just SSH in or like transfer files to and from. It's pretty cool. Yeah. Cool thing is that in order to edit some of the code, I used Sublime, and let me see if I can make this bigger. Oh, it doesn't change anything else. But rather than go through like the normal loop where you edit some code, push it to Git, and then Git Git pull from like the Raspberry Pi, I actually had a workflow that looked more like I would hook up to it immediately, and then I could choose what file I could edit and do it like inside the file, which is pretty cool. And so whenever I like type in something and press save, like that little process at the bottom bar will say success because I saved off of this console, which it was another cool thing that
Has this project given you any ideas for something you might want to do in the future for hardware?
So this was something that I kind of wanted to do for a while, like see if I can hit an endpoint and then bring back a response and use it somehow. So going back to like inputs and outputs, just being able to exercise that was a lot of fun. I'm currently in the process of thinking of other things I can do with the Raspberry Pi. Input-wise, like I don't know that much about sensors and stuff like that, but I would want to see if I can stick a sensor on the Raspberry Pi and then send data to a web server, like go the opposite direction and see what results we can do with that. But yeah, that's like another direction we can go in.
Yes. Yeah, what's up with that?
So this was my hello world. So if you look at the screen, this is the method that I use. And it looks a lot like that method that I kind of called in the Python code. There's a few other demos as well. I can like loop through them right quick. Doop. No. Let's do 0.
Oh, you have some others written?
So these are a part of like the software that I used. I didn't write any of the C code for this, and it looks kind of intense. I would want to do more along the lines of like hardware stuff in the future, so like maybe I can review that code and see what we can come up with. This is a pulsing lights. Oh, and our emoji sticker still works. That was pretty interesting. 6.
So you've got competing processes, both trying to modify the LED?
Yeah, so I think the way that the C code works is it just pushes. It like doesn't care about the state of the LED matrix. So if another emoji were to come by through here, actually let me do one right now.
Looks like it's testing all the colors.
Yeah, let's do eggplant.
Yeah.
Oh, I broke it.
God.
I think 7 is another one.
Oh, cool.
Oh yeah.
It looks almost generative.
Yeah.
That's the.
Is that Conway?
Yeah. Oh, okay.
You're interested in going the other way. I feel like Nick Alkaline has a little bit of experience. He did a project in our class that was similar to going like the opposite way. So, yeah.
That's cool. Yeah.
Have you considered adding like text to it as well, like so we can see what the exact thing of their excuse is besides the emoji?
I have thought of that, but I think
Yeah, but it's anonymous kind of, right?
so. Part of the challenge to that was for each emoji that goes across the screen, we actually had to create a file that was like mostly black space, and then in the last 16 pixels was the emoji, and that was so that we can make it so that when it comes across the screen, you don't get like the same emoji twice. So figuring out how to like maybe if we were to generatively like edit the image files themselves and like create like stuff like that, which would be pretty cool actually. That whenever you mess with the files though, that it's a little bit more intense, and especially on a Raspberry Pi, which only has like half a gigabyte of RAM, you have like that limitation as well.
Well, have you considered like upgrading the RAM for that?
I actually don't know if they do upgradable RAMs on like a board that small, but it would be something interesting to look into. They do? Cool. Okay. Well, I know what my assignment is.
Yeah, I think it's super cool how you have like all these different processes, but then at the highest level, it's just like what, 4 lines of code?
Yeah.
That just requests all of it. That's awesome.
Yeah, I think, because I definitely have like the shotgun approach to programming, where like you just kind of write as much code as you can, and then you scale it back.
Yeah.
And so after scaling it back, I was able to get it down to like that small.
Cool.
Yeah. Cool. All right, I'm gonna eat lunch now.